Hi everyone. Today we will discuss the 7th unit of first PU, the combined unit Principle of Mathematical Induction and Sequence and Series. Both are interrelated topics, and this sequence and series you studied in 10th standard. Arithmetic progression and geometric progression you studied in 10th. In first PU also, except harmonic progression, both AP and GP you studied. So let us start with the principle of mathematical induction questions first, and then for sequence and series. Observe question number 1. P of n 2 power n less than. Question number 1. 2 power n less than 1 into 2 into 3 etc. into n. So we have to select the smallest positive integer for which Pn is true. If I take the first option, n is equal to 1, that will be 2 power 1 less than n first term. This is not possible. Option 2, n is equal to 2, 2 square less than 1 into 2. This is also not possible. Similarly, option C, n is equal to 3, 2 cube less than 1 into 2 into 3. Not possible. The option D, n is equal to 4, 2 power 4 less than 1 into 2 into 3 into 4. So nothing but 16 less than 24. Option D is the correct answer. So here they are asking the smallest positive integer for Pn. So we substituted one by one. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. If I substitute n is equal to 4, 2 power 4 obviously less than 1 into 2 into 3 into 4. Therefore option D is the answer. Next one. A student was asked to prove a statement P of n by induction. He proved that P of k plus 1 is true for all k greater than 5. Also P of 5 is true, that is k is equal to 5. Two conditions. On the basis of this, he could conclude that Pn is true for n greater than or equal to 5, because greater than 5 and equals to 5. Option C. So here two conditions. One is P of k is true for k greater than 5, and it is true for k is equal to 5. Combining these two conditions, we can write n greater than or equal to 5. Option C. Next one. Third one. They have given one expression, 10 power n plus 3 into 4 power n plus 2 plus k is divisible by 9. They are asking k value. Let us take n is equal to 1. So you will get 10 power 1 plus 3 into 4 cube plus k. So this will be 202 plus k. So here, what is the least value of k if you add to 202, which is divisible by 9? If you add 202 plus 5, that is equal to what? 207. So 207 is always divisible by 9. So this will be 8, 9 3s are 27. So 5 is the least value of k to be added, which is divisible by 9. Option A is the answer. So n is equal to 1 is the basic step which we follow in principle of mathematical induction. Next one. Similarly for fourth one, 3 into 5 to the power of 2n plus 1 plus 2 into 3 power n plus 1. Let us take n is equal to 1. So this will be 3 into 5 cube plus 2 to the power of 4. So this will be 391. 391 is always divisible by 17. 391 divisible by 17. So option B is the answer. So here n is equal to 1, it becomes 3 into 5 cube plus 2 power 4, which is equal to 391, which is always divisible by 17. Go for next one, fifth one. X power n minus 1 is divisible by x minus k. Divisible by x minus k, nothing but x minus k here. The least positive integral value of k is. So here x power n minus 1 is always of the form x minus 1 into some expression. According to a cube minus b cube or a square minus b square, x power n minus 1 power n you can take. This is of the form x minus 1 into some expression. So to cancel these two, the k value should be 1. K value should be 1. So this is one method, or let us take n is equal to 1. If I take n is equal to 1, the numerator is x minus 1 divided by x minus k. So k value is 1. X minus 1 divided by x minus k. It is easily divided by x minus k when k is equal to 1. We'll go for next one. So these 5 questions belongs to principle of mathematical induction. Sixth one. A sequence may be defined as a function whose domain is a subset of natural numbers. Option C. Sequence is a function whose domain is always a subset of natural numbers. The definition of sequence is a function whose domain is always the subset of natural numbers. Option C is the answer. Next one. Seventh one. Observe seventh one. If x, y, z are positive integers, then x plus y, y plus z, z plus x is. You should know one thing. Whenever x, y, z are some numbers, we have one expression, arithmetic mean always greater than or equal to geometric mean. arithmetic mean greater than or equal to geometric mean. So therefore here there are three numbers. If I take x and y, you can write x plus y divided by 2 greater than or equal to square root of xy. This will be x plus y greater than or equal to 2 root xy. So this is the first expression. If I take yz, this will be y plus z divided by 2 greater than or equal to square root of yz. Y plus z greater than or equal to 2 root yz. Similarly, x comma z, x plus z divided by 2 greater than or equal to xz. X plus z greater than or equal to 2 root xz. So if you multiply all three equations, you will get x plus y, y plus z, z plus x greater than or equal to 8 into square root of x square, y square, z square. So this will be greater than or equal to 8xyz. So option B is the answer. So whenever three numbers are there, the value of expression x plus y, y plus z, z plus x is always greater than 8xyz. So here, we have one expression, arithmetic mean greater than or equal to geometric mean. So then arithmetic mean of x and y is x plus y divided by 2 greater than or equal to root xy. Cross multiply y and z, z and x. If you multiply all three equations, so you will get 8x root of x square, y square, z square. Option B is the answer. So let us take the next one. 8. So before going to the 8th one, sin 18 degree, I will tell you, sin 18 degree always equal to root 5 minus 1 divided by 4. Sin 18 degree root 5 minus 1 divided by 4. In a GP of positive terms, if any term equal to sum of the next two terms, then the common ratio of the GP. So here you know that AR square, this is the general sequence of AP. The general sequence of AP is AR square, etc. AR to the power of n minus 1. So let us take first three terms. According to this, any term A is equal to sum of the next two terms AR plus AR square. So divide by A. So it will be 1 is equal to R plus R square. So this will be R square plus R minus 1 is equal to 0. R is equal to minus B plus or minus root of B square minus 4AC divided by 2A. So here consider R is equal to root 5 minus 1 divided by 2. So R value is root 5 minus 1 divided by 2 is there, the common ratio. This common ratio root 5 minus 1 by 2, no option is there. But we are having this formula, sin 18 degree, nothing but root 5 minus 1 by 4. So therefore you can write this as So 2 into root 5 minus 1 divided by 4. You can write this because 2 2s are. This will be r 2 sine 18 degree. In trigonometry itself, I have given the value of sine 18 degree, cos 36 degree. So I will repeat once again, sine 18 degree, since they have given 18 degree and ar square, ar to the power of n minus 1, or in GP, general sequence, any term is equal to sum of the next two, divided by a. 1 is equal to r plus r square, that is r square plus r minus 1 is equal to 0. R is equal to minus b plus r minus root of b square minus 4ac divided by 2. R is equal to root 5 minus 1 by 2. If I take root 5 plus 1, this will be above 1 point something. So therefore root 5 minus 1 divided by 2. Divide and multiply by 2. This value you can take as sine 18 degree. Next, the ninth one. In an AP, pth term is q and the p plus qth term is 0, then qth term is. So we have one standard result. In an AP, Tp is equal to q and Tq is equal to p, which implies T of p plus q is equal to 0. So therefore the answer is the TQ is equal to P is the answer. Option B is the answer. For example, if I take T5 is equal to 10, T10 is equal to 5, T15 always 0. This 15 can be written as 5 plus 10. You can observe here this 5, 10, 10. So whenever this is matching, here observe P here, Q. And also we have one more result. TR always is equal to P plus Q minus R. This is one of the standard result. Suppose if they ask T20, this will be P plus Q, 5 plus 10 minus 20. This will be minus 5. T of P plus Q, whenever Tp is equal to Q and Tq is equal to P, T of P plus Q is equal to 0 and Tr is equal to P plus Q minus R. So therefore we have given Tq is equal to P. This is an example. T5 is equal to 10, T10 is equal to 5, T15 is equal to 0. Similarly, some number T20 is equal to, this is P, Q and R, minus 5. The same result you proved in the first PU. We'll go for next one. Tenth one. So this is a standard result. Here S is the sum and P is the product, R is the sum of the reciprocals. Are in GP. So here for GP you should take three terms, A by R, A, AR. Three terms are in GP. So here 3 terms are in GP, then P square R cube is to S cube. Nothing but here product P A by R R cancel. This will be A cube product and sum A by R plus A plus AR. So this will be A common 1 by R plus 1 plus R. Capital R will be R by A plus 1 by A 1 by AR. 1 by A common R plus 1 by R. So this is a standard result. P square R cube divided by S cube always equal to 1. Always equal to 1, that is 1 is to 1. Option A is the answer. 1 is to 1. So here they have given 3 terms are in GP. Whenever 3 terms are in GP, we can take A by R, AR. Here P nothing but product of 3 terms. S sum of reciprocal. S is the sum of 3 terms. R is the sum of reciprocals. So therefore that ratio is always 1 is to 1. This is a standard result. Go for next one. Eleventh one. Here 3 plus 7 plus 11 etc. 15, which is equal to 1 plus 6 plus 11 plus 16 plus etc. The 10th common term between. So here the first common term is 11. So here D is 4 and D is 5 here. Second common term so this will be the first term. 11 plus LCM of 4 and 5, that is 11 plus 20, that is equal to 31. First common term is 11. Second common term will be 11 plus LCM of 4 and 5. 4 is the common difference of first series and 5 is the common difference of second series. So therefore A is equal to 11, D is equal to 31 minus 11, that is equal to 20. They are asking 10th common term. T10 is equal to A plus 9D. 11 plus 9 into 20. 191. I will repeat once again. So here they have given 2 series. The first common term is 11. The second common term is obtained by adding 11 plus LCM of 4 and 5. 4 and 5 are the common differences. A is equal to 11, D is equal to 31 minus 11, that is equal to 20. 10th one they are asking 191. Option A is the answer. You should analyze the common term of 2 series, then you have to go further. 12th one. In a GP of even number of terms, the sum of all terms is 5 times sum of odd terms, the common ratio of GP. So here they have given one GP, even number of terms, nothing but 2n terms. Sum of all terms is equal to 5 times sum of odd terms. So here, if I write the geometric progression AR square, etc. up to 2n terms, AR cube. Now, sum of all the terms, A into R power n. Instead of n, you should write 2 power n. This is 2 power n terms, sum of all the terms. 5 into A into, what is the common ratio of odd terms? This is odd term, AR power 4. Observe, first term, third term, fifth term. The common ratio of odd terms is always R square. So therefore R square whole power n minus 1 divided by R square minus 1. The formula is A into R power n minus 1 divided by R minus 1. Sum of all terms nothing but 2n terms. Here sum of odd terms nothing but first, third, fifth, seventh, like that. The common ratio is R square. Therefore R square whole power n minus 1 divided by R square minus 1. So this will be R power 2n minus 1, R power 2n minus 1 cancel. AA get cancel. So this will be 1 by R minus 1 is equal to 5 times R minus 1 into R plus 1. R minus 1 cancel. R plus 1 is equal to 5. R is equal to 4. So the common ratio should be 4. If the common ratio is 4, then sum of all the terms is equal to 5 times the sum of odd terms. So here this is the general sequence, A into R power, instead of n, so we have written 2n nothing but 2n terms. So here the common ratio of odd terms is R square. So we will go for next one, 13th one. X belongs to R. The minimum value of the expression 3 power x plus 3 power 1 minus x. X belongs to R, they are asking. Minimum value of x. For this we have to use again arithmetic mean greater than or equal to geometric mean. So therefore arithmetic mean 3 power x 3 power 1 minus x divided by 2 greater than or equal to square root of 3 power x into 3 power 1 minus x. So this will be 3 power x plus 3 power 1 minus x greater than or equal to 2 times So here x and 1 minus x. If you add 3 power x plus, so I will write here 3 to the power of x plus 1 minus x. Cancel, you will get 3. So therefore you will get 2 root 3. Option D is the answer. Observe, 3 power x plus 3 power 1 minus x. Arithmetic mean greater than or equal to geometric mean 3 power x plus 3 power 1 minus x divided by 2 greater than or equal to square root of 3 power x into 3 power 1 minus x. Cross multiply, you will get 2 root 3. Fourteenth one. Observe 14th one. If the sum of n terms of AP is given by, then the common difference. For this, there are many methods. So before going to that, Sn formula is n by 2 into 2a plus n minus 1 into d. They have given Sn is equal to 3n plus 2n square, or you can write 2n square plus 3n. So the actual procedure is S1 find out, this will be 5, find out S2. So S2 will be 2 into 2 square plus 3 into 2. 8, that is 14. S3, 2 into 3 square (18) plus 9, 27. This is T1 itself and this is A, and T2 will be S2 minus S1. So that will be 14 minus 5, 9. Here T1, which is equal to A, is equal to 5. T2 will be 9. D will be 9 minus 5, that is equal to 4. T is equal to 4. This is one method. Option D is the answer. Or we have one more method. Directly you can write the shortcut method. Whenever sum is of the form an square plus bn, then common difference is always equal to 2a. Now observe the capital A. Capital A is 2 here, which implies D is equal to 2 into 2, that is equal to 4. You can observe once. Sn is equal to n by 2 into 2a plus n minus 1 into d. They have given Sn 2n square plus 3n. Find out S1, S2, S3. Here S1 nothing but first term, that is A. S2 nothing but sum of 2 terms. S3 sum of 3 terms. T2 is equal to S2 minus S1. You know T1 and T2. You can calculate the common difference. The common difference is given by 9 minus 5 is equal to 4. Or else you can use the standard result. You can use the standard result. An square plus bn, that is 2a. 15th one, the third term of GP is 4 and the product of first 5 terms, you can observe AR square, AR cube, AR to the power of 4, 5 terms. Third term AR square is equal to 4. The product of first 5 terms. The product of first 5 terms is A into AR square, AR cube, AR to the power of 4 is equal to. So this will be A power 5 R power 10. This can be written as AR square whole to the power of 5. That is 4 power 5. Option C is the answer. Observe here. 15th one, the third term of GP is 4 and the product of first 5 terms. Take the product of first 5 terms AR square, AR cube and AR power 4. Multiply this, you will get A power 5 R power 0. That is AR square whole to the power of 5, 4 power 5. Sixteenth one, if 9 times 9th term of AP, before going to that, nth term of AP is 9 times the 9th term is equal to 13 times the 13th term. They are asking T22. Again there are 2 methods. 9 times A plus 8D, A plus 12D, 9A plus 72D, 13A plus 156D. So this will be 156 minus 72, 4, 84, 84D plus 4A is equal to 0, 4 common, A plus 21D is equal to 0 or A plus 21D is equal to 0. This will be 22. So this is the first easiest method, that is 9 times T9 is equal to 13 times T13. 9 times A plus 8D is equal to 13 times A plus 12D. Multiply this. If simplify, you will get 84D plus 4A is equal to 0. Take 4 out, A plus 21D. T22 is equal to 0 or if I write PTP QTQ, which implies T of P plus Q is equal to 0. The simple one. Here P is 9. Q is 13. 9 times T9 is equal to 13 times T13 is equal to, which implies T22 is equal to 0. Directly you can put 0. Option E. So this is a shortcut method. Seventeenth one. 17th one, x plus, that is x 2y are in AP and xyz are in GP. Nothing but y by x always equal to z by y. Let us take lambda. So y is equal to x lambda, equate this. Z is equal to lambda y, and this z will be lambda times lambda x. Z is equal to lambda square x. So here 2y x plus 3z divided by 2. 4y is equal to x plus 3z. Substitute all the values. 4 into lambda x so divide by x, 4 lambda 1 plus 3 lambda square. So 3 lambda square minus 4 lambda plus 1 is equal to 0. So you will get lambda is equal to 1 or 1 by 3. So here 1 by 3 is the option. Common ratio 1 by 3. If you substitute lambda is equal to 1 by 3, then x 2y 3z will be in AP and xyz will be in GP. I will repeat once again. X 2y and 3z are in AP and xyz are in GP. Then the common ratio, in the option they have given 1 by 3, they have not given 1, so therefore 1 by 3 is the answer. Eighteenth one, in an AP, Sn is equal to Qn square. Sm is equal to Qm square. SR denotes sum of R terms of AP. Then SQ equals, let us take n is equal to 1. S1 is equal to Q. S2 is equal to 4Q. S3 is equal to 9Q. Vary n value. Then T1 will be always S1, that is Q. T2 will be S2 minus S1, that is equal to 3Q. So Q, 3Q, etc. The common difference will be 2Q. Common difference is 2Q. So therefore SQ is equal to Q by 2 into 2A. A is Q, 2A plus n minus 1 into D. Simplify this. Q by 2, 2Q plus 2Q square minus 2Q. So Q cube. So I will repeat this. If in an AP, Sn is equal to Qn square and Sm is equal to Qm square, where SR denotes sum of R terms. So here put n is equal to 1, 2, 3, you will get Q, 4Q and 9Q. T1, T2 you got it. You can find common difference, substitute in the formula, you will get SQ is equal to QQ. Next one, 19th one, sum of n terms of AP and S2n is equal to thrice Sn, then S3n divided by Sn is always 6. Standard result you can keep in mind, or substitute the sum formula. Substitute the sum formula, you will get it. So that is a very lengthy procedure. Better you can do like that. 19th one. Do 20th. So try 20th everyone. So we did the same problem using arithmetic mean greater than or equal to geometric mean. Twentieth is similar problem of previous. Four power x two into this will be x cancel, root 4 is 2 is equal to 4. Option B. (21) R is equal to 1 to n SR divided by SR. Sum of natural numbers. First one, Sn, capital Sn will be sum of the cubes, 1 cube, 2 cube, 3 cube up to n cube. That will be n square into n plus 1 whole square by 4. Small Sn will be sum of first n natural numbers, 1 plus 2 plus 3 up to n. So that will be n into n plus 1 by 2. So divide these two, Sn divided by small Sn, n into n plus 1 cancel. So you will get 1 by 2 times n square plus n. Apply the summation. Sigma n square, sigma n. Sigma n square will be n into n plus 1 into 2n plus 1 by 6. Sigma n into n plus 1 divided by 2. So you will get n into n plus 1 into n plus 2 divided by 6. So you can observe here, capital Sn nothing but cube of sum of natural numbers, and then small Sn will be sum of natural numbers, divide one by other, you will get of n square plus n, take the summation, you will get n into n plus 1 into n plus 2. So option A is the answer. 22. So here they have given 2 plus 3 plus 6 plus 11 plus 18 etc. So here very simple thing what we can do, 2 can be written as 0 square plus 2, 1 square plus 2, 2 square plus 2, 3 square plus 2 etc. The last one 49 square plus 2. For the first term 0, for the second term 1, for the third term 2, for the 50th term 49 square. So therefore T50 always equal to 49 square plus 2. Otherwise you can go for summation of finite series method. 2 plus 3 plus 6 plus 11 plus 18 etc. You can write first term 0 square plus 2, second term 1 square plus 2, third term 2 square plus 2 etc. So finally you will get 49 square plus 2. The length of 3 unequal edges of a rectangular solid black are in GP. The volume of the black is 216 and the total surface area, the length of the longest edge. They have given GP, volume is given by length into breadth into height, and surface area is given by 2 into LB plus BH plus HL. Since they are in GP, you can take L is equal to A by R, B is equal to A, and H is equal to ER. Substitute in this formula volume and surface area. They have given volume 216 centimeter cube and surface area 252 centimeter square. Substitute in these two, you will get R is equal to 1 by 2 comma 2. The longest side will be 12 centimeter. Since they are in GP, you should take A by R, AR. You will get the common ratio 2 or 1 by 2. The longest side will be 12 centimeter. Sequence and series is one of the easiest one. As you studied this one in 10th and PU, the continuation, go through every formula and all the problems. Thank you everyone. The last one unit is remaining, that is mathematical reasoning and statistics. Thank you.